All right, good. So we have another question. They say that prove that for any triangle, b squared minus c squared over a squared must be equal to that. So still shall say, this is very simple. Shall say solution, shall start from left-hand side. From left-hand side, you want to see that this is true, equal to that. Now, but before we do that, we can now say, okay, from left-hand side, you can now say that this is now b squared minus c squared over a squared. Now you can say that from 2r is equal to b, 2r is equal to a over sine a, which is equal to b over sine b, which is equal to c over sine c, like that. That implies that 2r is equal to a over sine a, and this implies that, okay, and this implies that when you try to make a the subject, your a will be equal to 2r sine a, comma, your b will be equal to 2r sine b when you make b the subject, comma, then your c will be equal to 2r sine of c. Then from there, we come and substitute this a, put it there, the b, put it there, and the c, do the same. So this will now be b squared, that will be now 2r sine b, but the whole thing there is squared, minus c, that will be 2r sine c. 2r sine c, but everything there is squared, over, all right, 2r, okay, sine of a, but everything is squared. Okay, this will imply that we shall have our factorials at once. 4r squared, since it is existing everywhere here and here, a factorize it. So here remain with b sine squared b plus, sorry, minus sine squared b minus sine squared c, like that, but over a 4r but squared a sine squared a. So this guy disappears with that guy. All right, good. But then in our proof, we don't have a. You have here b, c. B, C. We don't have a. But here we have a. So that a is in there, but in our proof, we don't have a. Now what you're going to do, shall now say, okay, can you detect a difference of two squares here? A difference of two squares here? Yes. That's now sine b plus sine c brackets. Then also sine b minus sine c. That is it. All right. Now over have a sine squared a. Now what does it mean? Since we don't have a is not appearing anywhere in our proof. What you now do, whenever you see this word here for any triangle, or if they say A, B, C are angles of a triangle in mathematics, then always, before you complete that proof, you must use this. So you shall start with say from, if there are angles, if it's a triangle, then this is true for a triangle, that the angles give us, the angle sum gives us 180. Now, since we don't have A in the proof, you make A the subject. You make A the subject. So now A will be equal to 180 minus A plus B. Please, this one you take it as a compacted, actually, B plus C. Minus B plus C. When you're taking this, you take it as compacted the way it is, so it becomes just minus. It's a sum there like that. Then from there, let's introduce a sign on both sides, just like we have it here. So this will be sine of A will be equal to a sine 180 minus B plus C. Like that. Now, you all know that when we try to expand here, a sine of A will now be equal to what? I want you to see it from here. When you have a sine of, say, for example, 180 minus theta, try to expand. This will be sine 180 cos theta minus cos 180 sine theta. I want to see the final result you get when you have this. Now, this theta of ours, take it to be the B plus C in there. I want us to save time a little bit with this. So sine 180, what do you get? Sine 180, what do you get? It is a 0. So this one becomes a 0. Then a cos 180, it is a -1. So -1 with this, it will just be sine theta. So what you must know is that a sine of this will just give you a sine of b plus c, like that. Now we take it back. There. Then also here we are going to apply factor formula. Even here factor formula. So you shall now say this will be equal to, apply factor formula here. We are adding these two, so that will be a2 sine, factor formula, we say a2 sine cos, okay, a2 sine cos. Okay, factor formula we shall say 2 sine, at the first point to add them, b plus c divided by 2, a cos b minus c divided by 2. Okay, good. Times factor formula here will be a2 cos a b plus c divided by 2 sine a b minus c divided by 2. Okay, but everything here must be over. Okay, a sine b plus c here, but everything is squared. Since everything is squared, since we are substituting for this, which was having a power 2, and sine a is this, but with the power 2, it will be like that. Now here we're going to arrange the ones with the angle b plus c come together, then the other ones go to the other side. So this will be equal to a 2 sine, okay, b plus c over 2, like that. Now let's bring another one with b plus c over 2. It is this one moves with that. It is one with a cos. A cos b plus c over 2. Good. Dot. Then your 2 remains. Here we shall have sine. Now bring down with minus b minus c over 2. Then again cos b minus c over 2. All right. Everything there must be divided by a sine of b plus c. But everything in there is squared. You allow me complete this up from here. I'll complete it up from here. Now that means that when you look at this, 2 sine b plus c of b plus c over 2 is 2 sine sine. 2 sine sine. It implies that from sine theta will be the same as 2 sine theta over 2 cos theta over 2. That's what you're having here. That when you have 2 sine cos, but when does have over 2, it means that originally you had this, a sine of a plus b. Take this to be theta. A sine of a plus b, or even I can write it for you. A sine of a plus b, when relating to that, will be a 2 sine a plus b over 2. No, this is not a plus b, it is b plus c. B plus c, okay. Even here, b plus c. I'm comparing from this to b2 sine b plus c cos b plus c over 2. I'm using double angle identities. Dot. Now here 2 cos. Here we have 2 sine cos, but with b minus c. That originally they had a sine b minus c, but over a sine b plus c, but then they have the power 2. Okay, let's see. It's like this guy is common with that power 2 shall cancel. Since that repeats itself, multiplies 2 times, so I've cancelled one of it. So we are remaining with the a sine b minus c over a sine b plus c. There is our proof. Yeah. Then you can say quite easily done. All right, let's look at the last example in this topic. We have, if AB is angles of a triangle, then prove that cos 2a plus cos 2b plus cos 2c is equal to that. Now I told you when you have different angles, always think about factor formula to prove this. And whenever you see this statement that A, B, C are angles of a triangle, then somewhere you must use the logic which says that A plus B plus C gives us 180. So let's start from left hand side. So from left hand side. Okay. So now when you have this question, you choose where you should start your factor formula from. Like personally, I will say I will go with this factor formula, work on these two guys. So now I will say cos 2a plus, now factor formula, I want factor formula which can work here. And cos plus cos will give us a 2 cos, cos plus cos will give us a 2 cos, okay? And again cos. By the first point you add, divide by 2. So 2b plus 2c divided by 2. 2b plus 2c divided by 2. So that these two will cancel with all those ones there. Just find that here we shall just get b plus c, then you shall just get b minus c. Please, 2b plus 2c, they can't subtract. But that coefficient of 2 you can factorize and you cancel out. So we have that finally. All right, good. Now, after reaching that level, what we are now going to do is, let us apply the double angle formula. Let us apply the double angle formula. The double angle formula for this one. So now we'll say that from cos 2a is equal to, we all know this, 2 cos squared a minus 1. We remember this from double angle identities, that when you have here 2, this must just be in that format. Now, that's what we need. Now I'll bring it back here. So that will be a 2 cos squared a minus 1 plus 2 a cos b plus c, again a cos b minus c, like that. Now next, what you're going to do is, let's now use the other ident of ab plus c. So now from a plus b plus c, okay, equals to 180 degrees. So you want to eliminate this a. I want to eliminate this a first of all. Now make a the subject. Making a the subject, or what I can do is, let me make b plus c the subject. So b plus c, the subject, will be equal to, right, 180 minus just that a, like that. So let's introduce cos on both sides. So cos on both sides, right. So this will be cos b plus c equals to cos 180 minus a. Why am I introducing cos? Is because here I have cos. I want to remove this a. I want this a to be similar to this b plus c. That's why I'm dealing with this a here. And I'm introducing cos because I have there cos. So therefore we shall say, in simple terms, this can be, okay, I'm only dealing with this part. So cos b plus c will be the same as what? You try to expand this. And that expansion, I want us to do it from here so that you can see. I will say cos, this is 180 minus a, will be the same as cos 180 cos a plus sin 180 sin a. But you all know that sin of 180 is 0, and the cos of 180 is negative cos a. Cos 180 is negative, then here it should be negative cos a. So this one here will be equal to negative cos of a. You can see that is equal to negative cos of a. Now it means that we can say that now a cos of a is equal to negative cos of b plus c. Now having done that, we are going to say in the name of cos a, we are going to put this. But here the science says that it is cos squared, so therefore it is in a bracket. But that cos is this negative cos a cos b plus c, close brackets, but squared. Please, I'm substituting for this area here. This area. Since cos a is that, now it will be, right. Allow me, this negative one will come last. So let me go to this plus 2 plus 2 cos b plus c, like that, dot cos b minus c, then in minus 1 at last, like that. That's how I want to make it up. The next, what you're going to do is, all right, this is squared, so let's factorize. Any common factor here? The common factor is cos. Okay, can have this 2 cos, okay, this one is like this, b plus c, okay, plus 2 cos b plus c, cos b minus c minus 1. Now what we're going to do here is common factor is cos b plus c, so therefore we shall say 2 cos, after 2 cos b plus c is a common factor. So you shall remain with cos b plus c. Plus, this has gone away, a cos b minus c. All right. Then a minus 1 there. So again here, come and apply factor formula in this level here. So this will again be a 2 cos b plus c. Apply factor formula there. This will now be a 2 cos, all right, a 2 cos. Now this plus this, b plus c, you see that, you see b plus c plus b minus c. This c goes away, b plus b is 2b divided by 2, shall remain with only b dot a cos. Since you're adding cos plus cos, here we're going to subtract, it's going to be b plus c minus b minus c. You see that the c will die out, the b will die away and shall remain with the c. So you shall have c there minus 1 in simple terms. So therefore, we are now going to say, but now here what we're going to do, since we are going to conclude, our answer doesn't have b plus c. Our answer doesn't have b plus c. Our answer doesn't have b plus c. So what we're going to do, let's bring back. We're having cos b plus c, you can report, we have cos b plus c. Cos b plus c, you can put a negative cos a. So yeah, this will be 2 into negative cos a dot 2 cos b cos c minus 1. That's what you're having. Now when you apply, you can start with the negative 1. This time this will be minus 4, a cos of a, cos of b, cos of c. 4 is coming from 2 times 2, like that. And I think when you look at that, we shall say quite easily done, or as required. That marks the end of trigonometry. The next topics shall see what to do. But of course, don't forget, when you do this, it gives us the energy to proceed to something else. It takes only less than 1 second. And please, you can also get the link and share to my WhatsApp group. Okay.